stuff. Here, do it. Okay, so during the 1800s, a Russian chemist, Dmitry... What? Molecule? Sorry? Who made the periodic table? Do you guys know?
I bet it was
Dmitry what? What's his last name?
periodic.
Periodic? No guesses?
Table.
That his name is Table?
It's gotta be something.
It's gotta be something, yeah. Mendeleev. M-E-N-D-E-L-E-E-V. Mendeleev. So he's the old dead guy that kind of devised the whole periodic table. So how did this happen? Well, old Dmitri was hanging out with some elements. Maybe he had some iron, maybe some mercury, because people were allowed to just play with mercury back then, and some sulfur or something. And he was examining these different elements, so he only had 62 at that time. He developed a table of these elements based on the fact that they had repeating properties. So what's property mean in this context? What's a property?
A characteristic.
A characteristic, yeah. So he could see that there were certain things that kept repeating themselves or they looked kind of similar. So the table was called a periodic table. Periodic table. For this reason. Because there were periodic things repeating. Okay? He further predicted the existence and properties of unknown elements and left spaces on the periodic table for them. So he like made the table, but there would be spaces like say here, 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 because he didn't have that element to work with. But he just predicted, okay, in that spot will be the element that has the atomic number 57, and it will have these characteristics. And then when they discovered it, it was like, yeah, that's totally exactly what it is. It's like, whoa, that's crazy. You know, like, isn't that amazing how elements can all fit onto a table where they're all like in line, they have exactly progressing numbers? Like, whoa, that's like a crazy pattern. You know, it's like exactly, there's not even one element that is out of line. Every single element fits into that pattern. Like, doesn't that feel like kind of a coinkydink or something? Like, it's pretty extraordinary when you stop and think about it. I don't know, I think it's crazy. But I think that, for me, that points to God as being this, you know, He's an amazing creator, and He loves patterns, and, you know, all of these things, they all fit together. They all have a purpose, and I think the table shows that, yeah?
How come ours doesn't have those ones in white? With what? Like the last, like the white letters.
See, there's some letters.
Oh, these? The plutonium, americunium? Yeah, you do have them. They're just not in the white. I don't know why mine are white. But you do have them, yeah. Elements are arranged according to increasing atomic number, and we talked about that yesterday. And remember, atomic number means number of protons in the nucleus. But since all atoms are neutral, it also indicates the number of electrons. Yeah. All right. So look at your period. Oh, oh crap, only 5%. That's a problem.
I got portable chargers in
Okay, I'll just do this video and then we'll get there. Thanks. Okay, so let's look at our periodic table. Now, there's one thing that really divides the periodic table, and it's called the staircase here. Okay, this big red line. Can you find the staircase on your table? Highlight it. Make your staircase kind of highlighted or make it, filled in. So it starts off boron, goes alumina, silicon, arsenic. You didn't get one? I put some extras over. Yes, it is. So everything on the left of the staircase, what is it? Metals. Everything on this side is all metals. And everything on the right is non-metals. So left of the staircase are metals. So these types of elements, what can we think of when we think of metals? What do metals look like? How do you know it's a metal? Solid. Okay, what else? Shiny, yeah. What else can you do to metals? Melt them. Okay. We say that they are malleable, meaning that they can be bent. They are ductile, means they can be stretched into a wire. And they can conduct electricity, yeah. So to the right, then, are nonmetals. So generally, the opposite of shiny is dull. The opposite of malleable and ductile is brittle, so it can break apart. And they do not conduct electricity. Surrounding the line are the, do you guys know this one? Pardon? Oh, the halogens are one type of group.
Oh.
What's around the staircase? Metalloids, we call them. And these elements, what do you think they display?
A bit of both?
Yeah, a bit of both. Both metal and non-metal properties. All right, the period number. So when we look at periods, periods what, go across or down? Yeah, they go across. So you can, that's why this is like red, red. So periods go across, then periods go across. Okay? Now, the way I remember that is, well, I'll get to how I remember it on the next thing. But the period, when we think about an atom, it will actually tell us how many energy levels, electron energy levels of an atom. So yesterday we talked about elements or atoms having electron energy levels. The period number will tell us how many there are. Properties change in two ways as you move from the left to the right. The element changes from metal to non-metal once you pass the staircase. And what else happens?
Reactive, non-reactive.
Yeah, so which one is which? When you think about going from the left to the right, when I move this way, do I get more reactive or less reactive?
Less.
Less, very good. Yeah.